Hey ho, in the last video we had a look at the null factor law as a way of finding the values of x for which a quadratic equation is true. And in this video we're looking at completing the square. And just as a quick reminder, this is the general form of a quadratic equation, a whole bunch of things equal to 0. And then this is what it looks like after it's been formatted into, it's called turning point form as the name, but it's after the completing the square process. So just going to get straight into it and have a look at a few different examples. All of these are kinds of things you might see in 3H, exercise 3H. So here's a basic example. X squared minus 6x plus 5 is equal to 0. And we'll follow the process as usual. So that means taking the middle term, which is 6x, halving that coefficient, so 6 divided by 2 is 3, and we keep the operation that's before it, like so. Notice that square shouldn't be there. That's what goes in brackets to the power of 2, and straight away we subtract that 3 to the power of 2. Just a reminder, doesn't matter whether this is plus or minus, you're always subtracting. And then we put the plus 5 on the end, and that's equal to 0. Let's tidy this up a little bit. So minus 3 squared is minus 9, plus 5 is minus 4. I'm just going to put the equal sign over there because I want to have a little bit more room. Okay, so that's the completing the square method done, but now we want to actually solve the equation. So we're going to do so by sort of unpicking left and right side here. So let me just put here in explanation onto the side here what we're doing. We're going to add 4 to both sides. That would leave me with x minus 3, squared on the left and plus 4 on the other side. Then we're going to square root both sides. And just remember that when we've got the square root of 4 is 2, but when we're using variables, when we square root something, an equation which has variables in it, then we need to take into account that there might be a plus or minus there. So I square root both sides. I get an x minus 3 on the left, and the plus and minus goes on to the 4 there. The square root of 4 is 2. Okay, so when I do the next operation, which is add 3 to both sides, I'm going to have a positive 3, right? So I'm just left with x on the left, and on the right, I'll put the positive 3 at the start, and then say plus or minus 2. This is just a usual way of going about it. If I then break that down, I've got x equals 3 plus 2, which is 5, or one solution or the other, x equals 3 minus 2, which is equal to 1. And that's my solution for that particular equation, x equals 5 or x equals 1. I'll pause here for a moment and say that's how completing the square works. It worked perfectly. It was absolutely fine. But it was a poor way to solve this particular equation. Pause the video and see if you can work out why I'd say that. Okay, so hopefully you've had a bit of a think about it. And if we have a look at this equation here, this is actually a fairly straightforward, I would argue, a fairly straightforward factorization. Minus 5 times minus 1 equals 5, minus 5 minus 1 equals negative 6. So this would factorize quite handily into x minus 5 times by x minus 1. And then the null factor law would give us x equals 5 and x equals 1. When you do exercise 3H, keep that in mind, that it doesn't tell you to use a particular method. It just says solve for x effectively. But I'd like you to focus on either using the null factor law or completing the square. Choose one or the other to see how you go. All right, 2 more examples just to take us through. Here's another one. Same process. Let's add the brackets in. It's plus this time, so I go plus, divide 6 by 2 and I get 3. So it's x plus 3 all squared. Take away 3 squared straight away, and then subtract the 2. And that's what equals 0. Tidy it up. X plus 3 all squared. Minus 3 squared is minus 9. Minus 9 minus 2 is minus 11, which is equal to 0. And then I'm adding 11 to both sides. So this is what I'm starting. So that's completing the square step done, and now I'm solving the equation. So we've got x plus 3 all squared is equal to 11 by adding 11 to both sides. Square root both sides to get x plus 3 equals. Now 11 is not a perfect square at all. So I'm just going to leave it as plus or minus to square root 11. That plus or minus there just reminds me that I've got two options at this point. Either add root 11 or take away at root 11. Now I'm going to subtract 3 from both sides. And I get x is equal to negative 3 plus or minus root 11. Now the way I would express that is i.e. x equals negative 3 plus root 11, or x equals negative 3 minus root 11. And that's it. That's all I have to do. You just leave it in that. That's called exact form. If you put it into your calculator, you could get a decimal answer. And sometimes it's useful to do so, particularly if you're plotting it on a graph. But yeah, that's what you have to do. Here's one more example, and this one has a coefficient in front of x squared. I just thought I'd do that just for the sake of it. So here we go. I'll do it fairly quickly. We factorize out the coefficient of a, and so that makes the middle term 4x 2x now, because we've got 2 times 2 equals 4. And we've got the minus 1 at the end as usual. Continue the factorization process. So we've now got x plus 2 all squared. Oops, sorry, that's wrong, isn't it? Halve 2 to get 1. So it's x plus 1 all squared minus 1 squared minus 1 equals 0. And then I'm just going to expand the brackets there to get 2x plus 1 all squared minus, now 1 squared is 1, 2 times 1 is 2, so it's minus 2 minus 1 equals 0. And finally, we've got 2 outside of x plus 1 all squared minus 3 is equal to 0. So we've now got it in perfect square formation here. I might just zoom out so we can see all of our options here. And I'll move on to slide 8 to do the next bit. We're going to solve it. So we add 3 to both sides. And that'll leave me with 2 outside of x plus 1 all squared is equal to 3. And then I can't square root. Well, I can, but I'd rather not square root until I've got the square all by itself on this side. I think it's better if you do that. So we're going to divide both sides by 2. It's going to use /2 like that for divide. And that leaves me with x plus 1 on the left, all squared, and 3 on 2 on the right. Now I'm going to square root both sides. And that leaves me with, I'll go up to the other slide 8 to finish this off. That leaves me with, scroll up a little bit so you can actually see it. X plus 1 is equal to the square root of 3 on 2. Okay, and you can leave it like that, that's fine. Sometimes it's good to simplify the surd by, if it was the square root of 9 on 2, you might make that 3 on root 2 or something like that. And then subtract 1 from, so it's plus or minus, I should say, and then subtract 1 from both sides to get x equal to negative 1 plus or minus the square root of 3 on 2. If you want to be really fancy, and I mean, and then we can split it, but I'll just give you the fancy bit here. Fast forward through the fancy bit if you want to. Root 3 on 2 is the same as root 3 on root 2. And we can do a thing called rationalizing the denominator. It's often seen as desirable, and I won't go through the reasons why, to have the root symbol removed from the denominator. So if I multiply top and bottom by the denominator, I end up with root 6 on top. Root 3 times root 2 is root 6. And root 2 times root 2 is just equal to 2. So root 6 on 2 is the rational answer. So therefore we can say x is equal to negative 1 plus root 6 on 2, or x equals negative 1 minus root 6 on 2. Both of those, but you don't have to. You could have left it as root 3 on the square root of 3 on 2, and that would have been fine as well. So there you go. There's a bunch of examples. Look, I know this video's gone on a bit, but I just want to do one last example that I didn't think of before, and I'm going to have to make it up as I go along, so forgive me if it doesn't quite work. Let's go with something like x squared plus 3x plus 50 equals 0. I think this would be okay. So if I use completing the square, I better make that one a bit easy for myself. Plus 4x plus 50. I think, yeah, that should be fine. So I'm going to complete the square as usual. So x plus halve 4 to get 2. So x plus 2 all squared. Straight away take away 2 squared and get 50. And the end here is it was at the first place. Then I'm going to simplify that. So that's x plus 2 all squared. Minus 2 squared is 4. So we've got minus 4 plus 50. So that's still positive 46 equals 0. X plus 2 all squared is therefore equal to negative 46. Okay, I just took away 46 from both sides. And now this is the warning. When I square root both sides, I will get the square root of negative 46. Okay, and the square root of 46 does not exist. There we go, D, N, E. To be more precise, it is not a real number. The square root of negative 46 does exist, but it's not a real number. It's what's called a complex number, an imaginary number. So long story short, this is an example to demonstrate a very simple property, and that is if you do completing the square and you end up with a positive number here, then you can conclude at that point that there are no solutions. In other words, this thing here where I said does not exist means that there is no real number that I can put in place of x and get that statement to be true. That's what it means. Okay, this video has already gone on long enough, so I'll stop there. And in the next video, we're going to look at the quadratic formula.